Okay, we're now on to the proof part of chapter 1 of proof and mathematical communication. So we've been looking at mathematical communication parts of it, so consequence and equivalence and inequality notations, but now we're on to the proof part. And for year 12 at the AS level, there are 3 types of proof that you need to be familiar with. And proof is something that often strikes fear into students or people. I think it's a nice topic, and we'll go through all the textbook questions on this, and hopefully by the end of these videos, you will be more confident with this topic. So proof. We'll go through it in this order, because that's what the book goes through it in. There are 3 types of proof that we'll be looking at. The first one today is disproof by counterexample. Okay, so that is where you disprove something. This is the only one where you're disproving it. Okay, so you're disproving something, disproving a statement by finding a single counterexample. Okay, which is different to proof by deduction and proof by exhaustion, where you're just trying to prove it. You're not trying to disprove it. Anyway, let's get into disproof by counterexample. That's what we're doing today. So section 3 in the AQA textbook. Okay, so let's read this together. It is not usually possible to prove that something is always true by looking at examples. However, it is possible to use examples to prove that something is not always true, and this is called a counterexample or proof by counterexample. Okay, so we're saying it's not always possible to prove something is true, so sometimes we've got to disprove something. So let's look at work example 1.6, and that's going to be it for this video, and then we'll look at the exercise 1C questions on this topic. So here we go. It says disprove by counterexample, okay, that x plus 1 all squared is equivalent to, okay, this means identity, so it's exactly the same thing as x squared plus 1 for all values of x. Okay, so with disproof by counterexample questions, often a good place to start is just by putting in the value of x and seeing what happens until you find the value of x that burns down the deck of cards, right, that disproves the statement. So let's go and do that, right? Let's just go and begin by putting in x being equal to 0 into this and seeing what happens. Well, if that is the case, well, we are going to get, on the left-hand side, we're going to get 0 plus 1 all squared being equivalent to 0 squared plus 1. Well, in this case, they are the same, because 0 plus 1 squared is just going to be 1 squared, which is equal to 1, and that is the same thing. That's identical to 0 squared, which is 0 plus 1, which is 1. So I've disproved nothing so far. So as it stands, right, that statement is true. But I just need one example to disprove it all, just one counterexample. So let's just try a different value. Okay, let's go and use x being equal to 1, and let's put it into our statements. Okay, so if this is the case, well, we're going to have bracket 1 plus 1 squared being identical to 1 squared plus 1. Okay, and what happens here? Well, we can see, well, 1 plus 1 squared is going to be 2 squared, which is 4. And clearly, right, that is not the same thing. 1 squared is 1 plus 1 is 2. So we can see here, right, that when x is equal to 1, this statement here, it breaks down. So it is not true. I found one example. There could be many more. In fact, it is the case with this example that any x value other than 0, so any non-zero value, will disprove this statement. But you just need to find one statement that I heard somewhere, I quite like it, that burns down the deck of cards, that just disproves the whole thing. And here I've done that with x being equal to 1, but it could be any non-value of x. And that is it for disproving by counterexample. Okay, so we'll go through the exercise 1C in the following videos, looking at the green questions, blue, and then the red questions, and that will be it for disproof by counterexample. Thank you.